Unit 1, Lesson 4, we're talking about inverse functions here. And in order to make sure we understand what a function is, in Algebra 1 they talked about that every input has exactly one output. If you're in class you get this nice dating story, but for right now we're going to move quicker than that, so don't forget input is x, output is y. So what we mean is every x variable has exactly one y value connected to it, okay? I don't worry about the y values, I only worry about x, and I'll show you that in just a second. To find the inverse of a function, you will be reversing or switching the input with the output. Okay, same vocabulary we just used, input and output, or you're switching the x variable with the y variable. Okay, that's the inverse part. Function part is a review from Algebra 1. We're going to review the function part right now. So if you had a table, always on the left are x values and on the right are your y values. Okay, so if we're deciding, as the question asks, is this a function? Notice that Abe has exactly one salary, Carolina has one, Darcy has one, Enrique has one, and George has one. All I care about are the x's. Every x has one y value. So I would say, yes, this is a function. What do I mean when I say I don't care about the y's? 500 has two different people that have that value. I don't care. I do not care what the output does. I only care about the input. Every person has exactly one salary, so we are a function. Okay? When you look at the inverse, what do I mean by inverse? They took the input and the output and they switched them. Notice that 500, 650, and 520 was y. It's now x. And the x values, who are our people, are now our y values. That's an inverse. They just switched places. I didn't make anything negative. I didn't do anything. I simply flip-flopped their places. So 500 belongs to Enrique, and it also happens to belong to Carolina. So when I do this right now, see these are my x values, I know it's not a function because I go to two different y's. Okay. We want to finish just to make sure. 650 belongs to Abe, and it belongs to Darcy. So again, not a function because this x value here has two different y values or outputs. Last but not least, 520 goes to George. Now this is the only one that did a good job. Everybody else is double dipping, so this is not a function. Okay? When I look at a table, the first thing they want me to tell them is this a function? Notice that all I care about are the x values, 1, 2, 3, 4. They're not repeated. In other words, they don't have more than one y value, so we're okay. So I would say, yes, this is a function. To find its inverse, I'm going to flip-flop. So x becomes y, y becomes x. Notice I did not change any signs. So this would be 8 and 2, 12 and 3, 16 and 4. Okay. Now, for an example in a table of what would not be a function, you do not have to write this, but you can put it down if you really want it. 2, negative 1, 0, 1, 2. Okay. To determine if it is a function or not, I look at all of the x values. I don't care about the y. And what I notice is I see 0 twice. Okay, so 0 has an output of 6 or a y value, but it also has an output of 9. So then I would say, no, this is not a function. No, it's not a function. Okay, and the reason it's not is that 0 has two different outputs. That cannot work. I don't care what y is doing. I never care. I only care that 0 has two outputs. No good. Okay, something that tends to confuse people, so I want to show it to you. Given this table right here, notice that the y value is the same the whole way down, but I don't care what y does. I only care about my input. This input has one output. This -1 has one output. This 0 has one output, and 1 has one output. So this is yes. This one is a function. Okay? I don't care that the outputs are repeated. I care if the inputs repeat. That's the only thing I care about. All right? Now, what happens if you're given a graph? Here, I've got some ordered pairs on the graph. And if I can write those down, then I can determine their inverses. Before that, I'm determining if this is a function. So I hope you remember from Algebra 1, we draw a vertical line down the page to determine if we have a function. Now the reason I do that is when I draw this line, this input 1 has exactly one output. Okay? If I drew my line over here, this input has exactly one output. So I can say that this one is a function. And then what I'm going to do is I'm going to come up with my points on the graph, and this is 2, 4. And so when I take the inverse, just like I did over here, I'm going to flip their places. So I'm going to go to 4, 2. Notice that they simply switched places. No negatives changed. 1, 2, 3, 4, 1, 2. There's my new point, 4, 2. Okay. This ordered pair right here is 1, 1, it looks like. Yes, 1, 1. The inverse of 1, 1 is still 1, 1 because they're the exact same number. All right, no change there. This point right here is 0, 0. And its inverse would also be, again, 0, 0, no change, because they're the same number. Be careful here, I went to the left one, so that's -1, and I went up 1, that's +1. So the inverse of that, I'm going to flip, is 1, -1. This is important. It is 1, -1. 1 at the back comes to the front. -1 at the front for x goes to the back as y. Make sure that you don't change signs. They simply slide position. This point is -2, +4. So its inverse would be 4, -2. Again, the 2 stayed negative, it just slid to the back. 4 is positive, it came to the front. So 4, -2, and you can see my parabola has turned sideways. These points, I got the inverse, so this is your inverse function. If you perform the vertical line test, right here, this 4 is dating 2 and -2, or has an output of 2 and -2. That's not okay. Remember, when I draw the vertical line test, I can touch it once, but I touch twice. I touch twice here. Okay, so this is a no. This is not a function. All right. Now, what we're concerned about ultimately is coming up with the inverse of an equation. So I'm going to give you 2 steps that you should write down. The first one is to switch x and y like we were just doing on the front, okay, in that table. And the second one is you have to solve for your y value. Okay, that's because we have a y equals button on our calculator. So first thing that you need to remember, f of x is y. If you don't know that, you need to be reminded of that because this is my y value right here. So I'm going to put x there because they're going to flip-flop. And I'm going to put y here. That is my first step. Now there is no such thing as an x equals button. So after I've switched my x and y, which I've done, I need to solve for y. You are going to reverse PEMDAS. So PEMDAS that you learned in middle school, parentheses, then exponents, then multiply, divide, add, subtract. When I have an unknown variables like we do, we work this backwards. So the first thing I always want to get rid of is adding and subtracting. Notice I have subtracting, so I'm going to add to both sides. These are not like terms. So I keep them separate. That is x plus 4. That's what I did, was I added 4 to the x, so that's what I have to write, x plus 4. 7 is multiplied by the y. So to undo that, I need to divide. Notice that it's to everything on this side. Now, 4 does not divide by 7 as a whole number solution. It becomes a decimal. So to keep from having to do decimals, we're going to write this fraction, keep it as it is, and y has to become your inverse notation. What does that mean? They originally gave me f of x, so I tell them, hey, f, this little -1 means the inverse. So that function you gave me, here's its inverse. That's the solution to this one. Okay? Now, number 2, I'm going to do the same exact first step, switch the x and the y. So I'm going to say x equals. Okay, all I did was change the x and the y. I did not move numbers, I didn't change signs, I kept everything the same. And I'm going to reverse the PEMDAS order. So I'm looking for addition and subtraction first. I see it here with -2, so I'm going to add 2. So again, this is x plus 2. They are not like terms. I don't put them together. They stay separate. Now, students have trouble with fractions. That is 1/2 times y. So normally I would divide. But I'm going to show you that if you punch in 1/2 and you multiply it by its reciprocal, which would be 2 divided by 1, oops, that means you flip it over, then you're going to get 1. So, to prove it to you, what if I have 2/3? I'm going to multiply it by its reciprocal, which means flip the fraction over, flip the fraction over, so 3/2. That's the flip. Notice that my answer is 1. Okay, it doesn't matter what fraction I use, 5/6, and I multiply it by its reciprocal, 6 divided by 5, again, flip it over, I'm going to get 1 every time, okay? So the point of that is showing you that I'm going to multiply this whole side by the reciprocal, 2 divided by 1. And 2 divided by 1 is actually just 2. Okay? You can still put it over 1 if it helps you in your notes right here, that's fine. But if you have it here, you should know what you're doing. Reciprocal, flip the fraction over. 1/2 of 2 is what left me with 1. That's what I want, 1y. Now you must distribute this 2 to both terms, so that is 2x plus 4. 2 times 2 is 4. 2 times x is 2x. Now when your y is alone, remember we don't use y, we use our notation. So we started with g, so we put g -1 of x. That means that g function you gave me, here's your inverse right here. Okay, the third one. So again, my first step is to switch the x and the y. Notice that I didn't change an exponent, I didn't change addition, I didn't change anything. Now my job is to get that y alone. I'm still going to work backwards, so I'm looking for addition or subtraction, and I see it. So we're going to subtract 1 from both sides. Now, hopefully you remember that the inverse of squaring something, if you don't know, it's on the calculator, and you don't even have to turn it on. Here is your squared button right here, and above it in blue is a square root. Those are inverse operations. Notice multiplication and division are by each other because they're inverses. Add and subtract your inverses, they're together. Square and square root are together. They're inverses of one another. So I'm going to square root the whole thing, and a square root are going to cancel one another just like adding and subtracting does. I'm going to square root this whole side. So I've got the square root of x minus 1. Notice the whole thing is under the root because it was everything that's over there. Now y is alone, so I'm going to look back at my original and I'm going to come up with the inverse notation. Okay? All right, where did 4? Oh, there's 4. I wrote over it. I'm sorry. Let me write 4 over here so you can see it better, because clearly I wrote over it. It says d of x equals 2x minus 12 divided by 4. Okay, so that's number 4. Sorry, I wrote on it. First step is to switch the x and the y values. And then a lot of students get stuck because they're not sure what to do here. I can't get rid of addition and subtraction first, like I've told you, because that minus 12 is stuck with this 4. This 4 is causing problems. That 4 means to divide. So the opposite of dividing is multiplying. Dividing by 4, multiplying by 4 will cancel it out. So I need to take this side and multiply by 4 as well. What I do to one side, I do to the other. Just like here, I was adding, I subtracted, I did it to the other side. Okay, so I'm going to do the same here. So I've got 4x equals. Now I've only got 2y minus 12 left. So in this problem, I had to get rid of division first because everything 2y minus 12 was trapped by that dividing 4. And I do that by multiplication. And now I'm ready, and now I have a problem that looks like what I've done before, where I need to get rid of subtraction. These are not like terms. X does not belong with terms that don't have an x, so I need to keep them separate. Okay, we know that these two became 0, so only 2 y's left. Again, 4x plus 12, not like terms, keep them separate. Just like x plus 2, not like terms, they're separate. X minus 1, not like terms. X doesn't go with something that doesn't have an x. Now I need to divide out my 2. Now this one's a little different. Up here, 4 was not divisible by 7. It's an ugly decimal. 12 is divisible by 2. But you have to check, because 4 also has to be divisible by 2, which it is. So when I do 4x divided by 2, I get 2x. Okay, so 4x divided by 2, then I have to do 12 divided by 2, which is 6. Okay, this becomes 1, so I go back to my original notation, d, negative 1 of x. So number 5 is very similar to number 4. Regardless, the first thing I'm going to do is always switch my x and my y value, because that's the first step to finding an inverse. Every time. Switch the x and the y. Okay. My second step is to try to solve for y. And I can't get rid of addition and subtraction right now, that plus 9, because it's trapped by this 6. That 6 is divided, so we are going to multiply. So we're going to have 6x. Why did the 6 go away? Because you have a division of 6 and a multiplication of 6. Those are inverses, just like adding and subtracting, so it's gone. Now I can follow this order over here, and I can get rid of adding 9 by subtracting it to both sides. Again, not like terms. X doesn't belong with something that doesn't have an x. They stay separate. 9 minus 9 is going to go away for us. It's 0. Now I'm ready to divide by 3. Notice it's to the entire side. And I say, hey, I know that 9 is divisible by 3, but 6 also has to be. And in our case, it is. So 6x divided by 3 would be 2x. Negative 9 divided by 3 is negative 3. 3 divided by 3 is 1. Y is alone, so we've got to go back to our original and do the inverse notation. So that is how you find the inverse from an ordered pair, a graph that has ordered pairs, a mapping, or even equations.